All right, we are on section P.5, factoring polynomials. So now we know how to multiply and divide and not multiply, divide, sorry, multiply and subtract polynomials. We're going to start looking at factoring, and factoring kind of leads us to what's going to be like division of polynomials later on. So we're going to go through and just go talk about factoring out a greatest common factor, factoring by group, techniques of factoring trinomials, and then remember those special cases where we ended up with a product of a sum and a difference. Well, that's going to give us our difference of squares. And then we have the ones where it was a binomial squared. So we're going to look at those as well. And then for fun, we're going to look at the sum and difference of 2 cubed. So when we talk about factoring, factoring a polynomial expressed as the sum of monomials. So we're meaning something that looks like this. Looks like monomial. Each one is a monomial. So when we have a polynomial in this form, when we factor it, it means find an equivalent expression that is a product. I don't know what it would be, but we're looking for some sort of product like this. This is probably not what it factors into. I'm just making something up, but we're looking for something like this. This is what we mean by factoring. So you've done factoring before, just not with polynomial. So when you've done factoring before, it's when we took something like 35 and we said, well, 35 is just 5 times 7. And with factoring, you get two numbers we multiply together, give us this number. Same idea, it's just that we're getting different. Usually it's going to be monomials or binomials that we have that would multiply together to give us the expression. Because one thing I always say to remember, it may not look like it because these are just this all represent a number, and this just supposed to represent the same number. The goal in factoring a polynomial is to use one or more factoring techniques until each of the polynomial factors, except possibly for a monomial factor, is a prime or irreducible, meaning we can't factor it further. In this situation, the polynomial is said to be factored completely. So we want to factor it to a point that I can't possibly do any more factoring. A polynomial or its factor is prime when it cannot be factored into a polynomial with a lower degree, or when there is not a common factor other than one among its terms. You're probably familiar with this. We want to factor out the greatest common factor. So the greatest common factor, which we usually call a GCF, is a expression of the highest degree that divides each term of the polynomial. So what we're looking for, we'll start with something a little easier. Let's say we had 25 and let's say 35 since we used it earlier. We want to find a number that divides both of these. 25 is 5 times 5, and 35 is just 5 times 7. So 5 is the largest number that would divide both. So 5 is the largest number that sorry, I had a cover there. That can divide 25 and 35. 5 is the greatest common factor. So remember that when we talk about factors, what we have here and here, those are factors. Factors are just numbers that we can divide into the original number. So 25 is divisible by 5 and 5, or you can also say 5 and 5 multiplied to give you 25, making those the factors. So for us, we're going to look at something a little more complicated times. What if we had something like 21x, 9xy, and 12x squared? Well, 21x, we could break that down into a 3 times 7 times an x. 9xy, that can be broken down into, let's make that equal. That is broken down to a 3 times y, x times y. And then 12x squared, well, that can be just broken down into a 2 times 3 times x times y. We want the largest number that will divide everything here. We see each term is divisible by at least 1 3, and each one of these terms would be divisible by at least 1x. So your GCF, greatest common factor, would be the 3x. That is the largest number that would divide into all of these. Okay. However, if let's say our numbers are, oops, that was supposed to be a y, 3x, 4y. Let me fix that. Just a little typo on the slide. If we had 3x, 4y, and 12y, what we see here is that this just breaks down into 3 and an x. This breaks down into, say, 2 times y. And then this breaks down into 2 times 3 times x times y. Not all of them have an x. Not all of them have a 3. Not all of them have a y. Not all of them have a 2. So there's nothing common here. So your DCF would just be 1. That is the only number I can divide into all those numbers. So when we say we want to factor out the greatest common factor, if I had 10x cubed and I had 4x squared, well, 10x cubed is just going to be 2 times 5, x times x times x. Or x squared is just 2 times x times x. So what we see here is that both of these numbers share at least the 1, 2. They share an x, and they share a second x. So my greatest common factor in this case would be the 2x squared. When we say we're going to factor out that 2x squared because it's my largest factor, what that means is this. If I have 10x cubed minus 4x squared, well, both of these are going to be divisible by a 2x squared. So if I divide x squared out of 10x cubed, all I'm going to be left with is a 5x. If I take 4x squared and I factor out a 2x squared, well, that means that all that's going to be left behind here if I divide this by 2x squared is just the 2. So we have this same term here. I can pull it out like this. Because now I just reverse the distribution, because if I distribute that back through, I'll be back to a 2x squared plus 5x and a 2x squared times 2. All we did was you just took the common factor and just pulled it out. This one, a little less work involved. We already see something that's common here that can be factored as we get this x minus 7. So sometimes it's not just going to be a monomial that we can factor out. It could be a binomial. It could be a trinomial. But we see we have a 2x times an x minus 3, and then we have a 3 times, or sorry, a 2x times x minus 7 plus a 3 times x minus 7. So because they both share that x minus 7, I can just pull that out, and I'm left with the 2x plus 3. Because once again, if I distribute this back through, we would have 2x times x minus 7, and we would have 3 times x minus 7. So we're just reversing the distribution. In this case here in B, we're going to see this again when we talk about factoring by group. Take a moment here and try to find your greatest common factor and factor it out of these terms here. So B is not quite exactly like we just did because we can factor something else out other than the binomial. So just pay a little closer attention to that. But you're trying to find the largest thing that I can factor out of both terms or all three terms. Okay, so we have 15xy squared. That's just a 3 times a 5 times an x times a y. We have 3xy, which is just a 3 times an x times a y. And then we have 33 x squared y, which is going to be 3 times 11 times x times y. Oops, yeah, I'm missing a y up here. So all three of these can at least be divisible by a 3, can at least be divisible by an x, and can at least be divisible by one y. This y doesn't have another y in the other terms. This x doesn't share in the other ones. So what we see here, the only things we're keeping is that 3, the x, and the y. This is my GCF. So if I pull out that GCF, I take 15xy squared and I divide out my 3xy, I'm just going to be left with 5y. If I take 3xy and I divide it by 3xy, the only thing that's going to be left over is 1. So I'm just taking out that greatest common factor. If I have 33x squared y and I divide that by 3xy, I'm just going to be left with 11x. So if I pull everything out, 3xy, I'm left with 5y minus 1 plus y to the x. And this would be the factored form. And I cannot factor any further because these terms here, there's not something else I can factor out other than 1. And then that's my binomial or monomial. That's the best we're going to do there. Okay. Now for B, one of the things you can do is you can factor something more than once. So let's just do what we saw before, is that we have x minus 5. Well, I can factor out that x minus 5. And then what's going to be left over is that 2x minus 4. This isn't completely factored. I can still do some more factoring because we have a 2 and a 4 here. So both of those are divisible by 2, meaning we have an x minus 5, but also I could pull out a 2 from both of these terms, and I'm left with 2 times x minus 2. So usually to make this look nicer, if we have just a monomial, we write that first. So we write that 2, x minus 5 times x minus 2. Don't worry that you have to do it all at one step. Sometimes you'll factor something out and you realize that you can go back and there's more that you can factor out. All right, so this is going to lead us, like I said, into factoring by groupings. So some polynomials have only a greatest common factor of 1. However, by a suitable grouping of the terms, it may be possible to factor further. This process is called factoring by groups. So we'll see what this means here in a second. So sometimes you can't factor out a greatest common factor. If you do, there's still some factoring you can do further. When factoring by groupings, we pair two terms and we factor out a GCF from among the pairs. This process may reveal other factors. So for us, we'll reveal other factors because we're practicing. Doesn't mean that this works all the time. We're using examples that do work. So when we talk about factoring by groupings, what we're going to do is we're going to put these together and call them a group, and these terms together and call them a group. So we have x squared plus 5x squared is going to be one group. And then we want to keep that negative there. So I'm going to just say plus negative 2x minus 10. That's my other group. Now here we have an x cubed and an x squared. So what I can factor out of both of these terms is an x squared. So if I factor out an x squared from x cubed, we're just left with x. If I take 5x squared and I factor out that x squared, we're just left with 5. Now over here, we have a negative 2x and a negative 10. Both of these numbers are divisible by 2. And not only that, a negative 2. So we can factor out negative 2. And then if I take this negative 2x and I factor out negative 2, all that's left behind is positive x. If I take negative 10 and I divide that or factor out negative 2, we're left with positive 5. So here individually, there wasn't a GCF other than 1 because not everything has an x, not everything has a 2, not everything has a 5. So we don't have any common factors here. But with this grouping we see now, we do have a common factor. We have x5 can be a common factor. Like we saw before, well, I can factor out the x plus 5, and then what's left over would be that x squared, and what would be left over here is that minus 2. So at this point, I will let you know you cannot factor this any further. Later, you might look at this and wonder if you can. This is as far as I can go. This is completely factored. Okay, so like I was saying, if you end up 4 terms asked to do factoring by group, this technique should work, but it does not always work for every time that you're given 4 terms. It's another example, 6n cubed, 3n squared, plus 8n plus 4. We're going to put the first 2 terms together. And then we'll put the second 2 terms together. So we have a 6 and a 3. We can least factor out a 3. We have a n cubed and an n squared. We can least factor out n squared. So 6n cubed. And if I divide or factor out that 3n squared, leaves me with 2n. And then my 3n squared, if I factor out 3n squared, just leaves me with 1. Because remember, essentially what we're doing here is when I'm pulling out this factor, I'm taking the other terms and I'm dividing by that factor. If you weren't seeing that. So because I'm multiplying, I need to divide it to make sure it evens out. But then once I do that, we're just left with the 2n here. And in this case, we're just left with the 1. Sometimes that little step helps people see that. That's really what we're doing there, is because we're like multiplying by the 3n squared, but we're also dividing by the 3n squared. So that's how it keeps this being the same, not the same, but equivalent expression. 8n and 4. So in this case, both of them, we can pull the 4 out. They're both divisible by 4. So it's really like we're going to take that 4 and then multiply by it, so that n has to be divided by 4, leaves me with 2n. And then my 4 has to be divided by 4, which leaves me with 1. So we have a 2n plus 4, or 2n plus 1. We factor that out. So keep the parentheses because you're factoring out that whole binomial. You're not factoring, you just want to make sure that's all together. And then we're left with 3n squared plus 4. Yes, so that doesn't factor any further either. So completely factored. All right, so take a moment with your worksheet and work on these ones and try doing factoring by group. Like I said, just do the best you can, and then we'll come back and we'll do it together. All right. So we're going to put the first two together. Bear in mind, it doesn't always have to be the first two and then the second two. You can rearrange it if you want to. Sometimes that is easier, which I may do here with B. We got this arranged now. And we can see here that we can factor out at least both of these are divisible by an x squared. So we're going to take out the x squared. I'm going to write that little extra weird step in there. So x squared, basically, we're going to take 2x cubed divided by x squared. And we're taking x squared and dividing it by x squared. And then here we can factor out at least a 3. We can factor out the 3, which means essentially we're going to divide it out of all of our terms. So we have x squared, and we are going to be left with 2x minus 1 plus 3 times 2x minus 1. So both terms have a 2x minus 1. It has to be the same binomial. If it isn't, it's not going to work. And then what's left behind is that x cubed plus that, sorry, x squared plus the 3. Like I said, it's distributed back through. We'd have x squared, 2x minus 1, and we would have plus 3 times 2x minus 1. B here. I'm going to do twice just so I can show you something else you can do here. So I want to expose you some things that could happen. We'll put these together and then we'll put these together. So we're going to have 9x cubed plus 6x squared is one of my groupings, plus negative 3x minus 2. So here we can pull out a 3 and an x squared. If I divide 9x cubed by 3x squared, then it will leave me with 3x. If I take 6x squared and divide by 3x squared, that's just going to leave me with 2. So here, the only thing that is common is they both have a negative. So I can factor out a negative 1. Sometimes we'll see that's where only thing we can do is factor out a 1 or a negative 1. If I factor out the negative 1, then I'm left with 3x plus. And that means if I can take out that 3x plus 2, then what's going to be left behind is my 3x squared and the minus 1. Okay. I'm just going to do B again here. One of the things I said is that I could do this in a front order. I can go, well, maybe I want the 3x squared here, and then I'm going to do the 3x because both of those I know are divisible by 3. And then I can put the 6x squared with minus 2 because I know both are divisible by 2. Or maybe I just don't like factoring out negatives. you could take this and just rearrange the order of your terms. And this is going to be a group, and this is going to be a group. Both of these are divisible by 3 and an x. I only have one x here. 9x cubed divided by 3x would just be 3x squared. And 3x divided by 3x is just minus 1. Here we can notice that both of these are just divisible by 2. So I factor out a 2, leaving me with 3x squared minus 1. So I can pull out the 3x squared minus 1, and I'm just left with 3x plus 2. You see we're getting essentially their equivalent expressions. They got the same binomials, just the order is different. But we end up getting the same solution or the same factoring here. Like I said, it is an option if you're struggling with trying to do your groups that you can rearrange the order of your terms, and maybe it'll be a little easier for you to deal with. So factoring a trinomial of the form ax squared ax squared, so I didn't do that right. Ax squared plus bx plus c. Sometimes when I save these things go wrong on the slides. A strategy for factoring, like I said, ax squared plus bx plus c. So we're gonna do a couple of these. One of the methods that we can use here is it kind of like a guess and check method. Is we're going to find two terms that are going to produce that ax squared. What we're going to do is we're going to find two terms that produce that last c. And then after I do that, I'm going to play with them and see if I can get the middle terms that I need to get this b. So it's a guess and check method. After I do this one, I'm going to walk through some other ones, but some people it's just easier to do the guess and check. So we're going to do a guess and check method for factoring a trinomial. So, like I said, this method is made really, really easy if what we see here, I don't have an a, basically my a is equal to 1. So if a is equal to 1, we make this guess and check method very, very easy because all we're trying to do is essentially we're trying to reverse a FOIL. That's all we're trying to do is trinomials if we're trying to factor them. So if a is equal to 1, we're trying to find two terms that are going to give us this x squared, which pretty much this is a choice of an x and an x. And then we're trying to find two terms that'll give us that c. And then we're just trying to find the combination that's going to give us the center. Just to kind of explain this again, how this is working. So if I had two binomials, x plus 2, x plus 5, and I multiply those together, we get an x squared. We get an x times 5, because that's my outers. I got a 2 times x, that's my inners. And then I have a 2 times 5, which is 10, which is my last. So what we see here is that these two numbers, 2 times 5, right here. 2 times 5 give me that 10, but that 5 and that 2, when they add together, give me that 7. We can reverse this pattern is what we're trying to do here. So we're going to do our best to simplify it. So like I said, so if we ended up with, oh, I just showed that part. If we're trying to reverse a FOIL, so let's say we have x squared plus 7x plus 10, we know that there's two numbers. We're going to call them p and q because we don't know what they are. We know there's a p and q such that, because like I said, this first one was x squared. The only thing it can possibly break down to is x and x are my two factors, is that we're going to have two terms that are x plus whatever one number is and x plus whatever the other number is. And what we know is that p and q are supposed to give me 10, and p plus q are supposed to give me 7. because that's what happens when we multiply these two terms to the FOIL. And that's what I'm showing you here. So what we need to do is just find two numbers for P and Q that would give us a 10. So we have some choices. 2 times 5 gives us 10, right? So we already saw that one. So I go, okay, well, does 2 plus 5 give me 7? And yes, it does. So it tells me that I can go backwards and go, oh, well, P and Q are just 2 and 5. Okay. I made these little charts for us to help us out. Okay, I fixed this one. I don't know why it's so did this. So what we got here is we have x squared plus 10x plus 21. We know there's two numbers, P and Q, that when multiplied together should give us 21, and that P plus Q give us the middle term of 10. So this one's because of this one comes from a product, this one comes from a sum. So we need pairs of factors. So 21, well, my choices are pretty much 1 times 21, which is going to be multiplied and gives me 21. If I add those, 1 plus 21, well, that's going to be 22, so that is definitely not a 10. So this one not work. We have 3 and 7. Those multiply together and give me 21. And 3 plus 7, if I add them together, give me 10. And this is what I wanted. I wanted a 10 here in the center. These are the factors I need. So my pairs of factors are going to be 3 and 7. So that means that we have x squared plus 10x plus 21. We need numbers that multiply to give me an x, so we know that's going to be x and x. We need two numbers that multiply to give me that 21, which we said are going to be 3 and 7, and we already tested it, and we know that those would also add to give me that. And it's always advisable that once you find your two factors, check to make sure that everything is working. So if I do FOIL this, I'm going to get x squared plus 7x plus 3x plus 21, which when I simplify is x squared plus 10x plus 21. Check it out. So this, in fact, is my factorization. So x squared plus 10x plus 21 factors into x plus 3 and x plus 7. Constant, a constant, sorry, a constant positive term. So when the constant term of a trinomial is positive, we look for two factors whose product is positive. Both factors must either be positive or they both must be negative. If the middle term is negative, both factors will be negative. If the middle term is positive, both factors will be positive. So back here, this was positive, this 21. This 10 was positive, meaning we had two positive factors, 3 and 7. So what we're saying here is that this tells me simply by being positive, I'm looking at two positive factors or two negative factors. All right, so we're going to look at this case here. We have x squared minus x minus 21. So remember, there's an invisible one here. So we need two factors, a p and a q, that multiply to give me the last term, that 20. And we need that p and q to be added together to give us this minus 1. All right. So in this case, we got a negative number, we got a positive number, because we need two factors that are going to give me a negative 20. We're pretty sure one has to be positive, one has to be negative, which is a mistake right here. I need a negative 20. things we could try. We can try, well, let's try 5 times minus 4. That will give me negative 20. However, 5 plus negative 4 is going to give me positive 1. So it doesn't work. Well, we can try 2 and we can try negative 10. That'll give me negative 20. But 2 plus negative 10 is going to give me negative 8. That doesn't work. One of the things you might have noticed here is that this one was really close. The 5 times the negative 4 gave me the negative 20 and added gave me a positive 1, but I want a negative 1. So when you see this, I would suggest going back and go, you know what I could do? I can flip these. What about if I had a negative 5 and a positive 4? That still multiplies to give me negative 20. Minus 5 plus 4 will add up to give me negative 1. One of the things to be careful just to watch out for is that when you notice that you get the correct number, just the wrong sign, that means just to flip which one has the negative, which pair. So here we'd see, well, what if P would be negative 5 and our Q was 4? So we'd end up with x squared minus x minus 20. We think probably factor into x minus 5 and x plus 4. So we're just going to check it and make sure that is in fact what happens. X minus 5, x plus 4. And I'd always advise checking because a lot of times you'll make little mistakes that you don't catch until you check. So x times x. My first is an x squared. Outers, x times 4, 4x. My inners, negative 5 times x minus 5x. And my last, negative 5 times 4, negative 20. Simplifies into x squared minus x minus 20. Notice that the last number here, this was negative. First time we had a constant term that was positive. Now my constant term is negative. So when the constant term of a trinomial is negative, we look for 2 factors whose product is negative. One of them must be a positive and one of them must be a negative. So we need a positive factor and a negative factor. The constant term is positive. We need 2 positive factors and 2 negative factors. And if the constant term is negative, we need a positive factor and a negative factor. Usually what's going to trip you up here is that when you're trying to figure out 2 numbers that multiply to give you that constant, is that you tend to overlook something, and usually you overlook it because you forget about you can divide by 1, and you also overlook it because you forget about negatives. So on your worksheet, work on A, B, C, A, B, and C. I don't remember if there was a B. And then come back and we'll go through A, B, and C. So worksheet number 3. All right, so we have x squared minus 12x plus 20. So we need 2 factors. Let's get my red back. 2 factors that multiply to give me 20. And that when I add them would give me negative 12. So we need 2 numbers that are positive. 2 numbers that when we multiply give us a positive 20, which should add to a negative 12. So my choices here is that I need 2 positive numbers or 2 negative numbers. So it's not worth looking at positive pairs because we know we have to add them to something that's negative. So what would probably be best to try out? Would be negative. Actually, let me start here. You probably want to start with like negative 4 and negative 5. Negative 2 and negative 10. Negative 1, negative 20. These are ones we'd want to start with because we know the product's going to be positive and we know the sum would have to be negative. Either case, all these will give me a positive 20 because they're 2 negative factors. The question is, when I add them together, what happens? We'll get a -9 here with -4 and -5. -2 plus -10 would give us a -12. Oh, I got what I needed right here. So I don't need to bother with the rest. Even though I have this one set up, we don't need to bother because this should only happen one time. Oh, my factors should be x minus 2 and x minus 10. And you can check those will work. Those are the two factors that we need. All right, so B, we got x squared plus 6x minus 5. So we need two numbers that multiply to give us the constant term, so that minus 5, that add together to give us that middle term of that 6. All right, so what can we try? So we got -5, we're pretty much at -1 times 5 would work, or +1 times -5. They're really my only two options, so we have to hope one of these works. So we want them to add together to give me 6. So -1 plus 5 gives me 4. 1 plus -5 gives me -4. I don't have any other options here, and none of these add up to 6. So what we have here is that this one was not factorable. So if you cannot factor it, you get to that point, you're like, I don't know. And that's a good place to be. You don't know. Can't factor this one with any of the techniques that we know of currently. This one is a prime trinomial. So I mean it's prime, we mean can't be factored. Can't be factored with rational constants and coefficients. No, it can be factored with other things. That's just not anything that we have currently. So one of the things we'll eventually go through is a quadratic formula, and quadratic formula can help us factor this. It's not usually what we use it for. I mean, that can't be factored with rationals. It means that when I factor this, it's gonna have like some square roots or something like that involved. And I don't know what the square roots are being. I'm just making something up. So we have x squared plus 2x plus 4. And once again, you have two numbers that will work. So it's either 2 times 2 or -2 times 2. That will give you the 4. Once again, we're going to see that when I add those together. Oh, there's one other combination. If I add those together, I get 4. If I add these together, I get 4. Well, I do have other option. I have 1 times 4. That will give me 4. Once again, if I add those together, that's not going to be 2. And I can do -1. -4 will give me +4. But once again, when I add those together, I'm not getting a 2. This is also a prime trinomial. Another method that we have to, like I said, there's that guess and checking that we could do. There's another way around using that guess and checking as well. If we have, well, it looks like x squared plus b x plus c, but a is anything other than 1, then we can use something called AC method. So when I mean that A is something other than one, that means it has to look like before we had like square and there was no number in front of it. Now we have something in front of it. So we have something other than one. Kind of goes along with that reverse FOIL idea. We can talk about the steps. Really, it's going to come down to, remember, trinomial is going to look like its standard form as this ax squared plus bx plus c. So we're going to multiply the leading coefficient. So we're multiplying that a to the c, which is where we get the AC method from. And the reason we do that is because eventually we get kind of like something that happens to give us that middle term. So we want to try to find factors that produce the A and C so that the sum of the factors will give us that B. So it's very similar to what we were doing before. It's just that we have that first step of the A times C. So we're not trying to find two numbers that give us C. They're products of C, the products to give us C that are sum to give us B. We're looking for products of A times C that sum to give us B. We're going to split the middle term and then we're going to use factors by grouping to figure it out. So before I do AC method and you tell me that you hate it, let me do guess and check. So I have 8x squared minus 14x plus 3. So what I know is that I need numbers. I need two numbers that multiply to give me 8x squared. Well, I can try 2x and I can try 4x. Those multiply to give me 8x squared. And then we know the two numbers here and here, those would multiply to give me that 3, so I can try something out. So, well, 3 and 1 would work. So if when I FOIL it out, we got 8x squared plus 2x. Already something is going wrong here. We got 3 times 3 times 4x, that's going to give me 12x. 3 times 1, that is going to give me 4. So already we guessed and checked it. And I actually guessed and checked this pretty well, to be honest. Well, that doesn't work. Oops, 3. Last term should be 3. What your guess and check method does. So sometimes your guess and check method works really well and we'd pop out right away. What's wrong here is I should use the -3 and a -1. But like I said, this is what guess and check method does. So once I do that, I'd go, well, if that didn't work, let's try something else. 8x squared plus 14x plus 3. Well, we can try maybe an 8x here and an x here, and then we can do -3, -1. So I do know what the answer is supposed to be. I am perfectly picking this wrong, but the point is you see that I'm already doing one trial here, and now I have to do it again. Let's FOIL this. 8x squared minus 8x minus 3x plus 3. 8x squared minus 11x plus 3. Oh, well, at least it's negative now. If you get stuck on this, like some of these could be really, really a big pain. Like this one's actually pretty quick and easy because I really am very limited. I only think I have like 6 things I can try. Um, maybe 8. But this can be a very cumbersome method when you're trying to sort of guess and check your way through this. So AC method, it's going to seem like a lot of work, but it's a lot quicker. So remember, 8 is your A, this -14 is your B, and the 3 is your C, right? Because it's A x squared B x plus C. So I need to multiply my A and C together. That would be my 8 and my 3. So I get 24. What about a pair of factors to give me 24? I'm looking for the AC. This part here, I'm looking for the B. So I need those two factors to add together to give me minus 14. Okay. So we know that this is supposed to be negative, so we need two numbers that give us a positive product, but give us a negative sum. So we need to know we need two negative factors. So I could try -1 and -24. I could try -2 and I could try -12. I can try -3 and -8. There's one more I can try. I can try well, 4, 6. I think that's it. All of these would give me a positive 24 when I multiply them together. The question is, which ones add up to a -14? So -1 plus -24, we already know this one is not going to be it. -25, so no. -2 plus -12, that's going to give me -14. So that works. No point trying the other ones. We know they're not going to work. So we could say here that, well, we got our P and our Q. Give me that -12 and that -2. So with AC method, what we do is we do our 8x squared minus 14x plus 3. And what we're going to do with that P and Q, so this technically happens in the other method when we have A is equal to 1. It's just that you don't see that step. But what happens is that I'm going to take the middle term here, and it's going to be broken down into that P and that Q. So in our case, it's going to be 8x squared minus 2x minus 12x equals 3. Because -2, -12, we might put them together, give us -14. So it's going to break up that middle term. So then we're going to do groupings. We're going to factor by group. So what we see here is that 8x squared and 2x, we can factor out a 2 and an x from both, leaving me with 4x minus 1. We have -12x plus 3. So because we have a negative out front, we're going to factor out a negative. Both those are divisible by 3. Let's factor out -3. -12x divided by 3 leaves me with 4x. -3 divided by -3 would leave me with -1. We haven't seen that one yet in a grouping. From here, I just pull out my 4x minus 1, and I'm just left behind with a 2x minus 3. Like I said, I was really close with the guess and check by random guessing that the problem was that I had a +1 and a +3, and it should have been -1, -3. But like I said, you just make a mistake and then you just keep on going. So here it's maybe a little longer process sometimes. But the guess and check method, you might be guessing and checking, like I said, 8 times before you find the right combination. This usually helps you get to it much faster. And technically we should check it. So let's just check over here. I think I caught something here. So 4x times 2x is 8x squared. 4x times negative 3 is negative 12x. Negative 1 times 2x is negative 2x. And negative 1 times 3 is negative 1 times negative 3 is positive 3. We have 8x squared minus 14x plus 3. Sorry, I have to restart everything here in a second. It's glitching. Okay, so we're going to try this again. You usually find about 2 or 3 times of doing this, people start picking up the method and you start feeling better about it. So A, B, C. So we want our A times C. So that will be 4 times 15. So that will be 60. So I need two numbers to multiply to give me 60. And then they're supposed to add together to give me this B. So they're going to add to give me that 16. So we need a pair of factors to give us AC, but some to give us B. So I think we can easily see that two numbers will work here. 6 times 10 will give me 60. And 6 plus 10 will give me 16. So we're going to take 4x squared plus 16x plus 15. And it's the 16 that we're going to break up. We end up with 4x squared plus 6x plus 10x. So we'll do a group here and a group here. So both of these are divisible by 2 and x, leaving me with 2x plus 3. Both of these are divisible by 5. If I divide a 5 out, then I'm left with 2x plus 3. And now if I pull out my 2x plus 3, because it's the same binomial in both, we're just left with the 2x plus 5. And if you want to, you can go back and check that one as well. All right, so worksheet number 4, you have A, B, and C again. Take a minute, work on those, and we'll come back and work on them together. If you get practice, sometimes you can just see what you break up this term into. But we want my A times C, so that is my 2 times negative 6, which will be negative 12. So I need two numbers that multiply together give me negative 12, but add together to give me that middle term of negative 1. So we can try, let's say negative 3 times 4. Those are products give me negative 12, but if I add them together, give me positive 1. Well, let's flip it. Positive 3, negative 4. Well, if I add those together, I get negative 1. That means that 2x squared minus x minus 6 can be rewritten as 2x. We get the factors of 3 and 4, so we can say plus 3x minus 4x minus 6. Okay. So we'll leave it like this. If you want to, you can flip things around a little bit. Sorry. If I do my group, only thing I can divide out of here is x. Will leave me with x plus 3. That's one of my factors. Here, both of these are a negative 4 and a negative 6. I could pull out a negative 2, and negative 4x divided by negative 2 would be positive 2x. Negative 6 divided by negative 2 would be positive 3. So I pull out 2x plus 3. What's left behind is x minus 2. Okay, so B, we have A times C, so 8 times negative 3, so negative 24. So I need two numbers that multiply to give me negative 24. but add to give me the middle term, so add to give me 2. So I think what we probably use is -6 and 4. Those multiply to give me -24. But if I add them, we get -2. Remember that when that happens, switch the negative. So 6 plus -4 is a +2. So now we have 8x squared plus 6x minus 4x minus 3. So if you don't like just pulling this negative out of two numbers, you can rewrite this. It's a little easier to handle and switch those two middle terms. Sometimes it just makes it something that's easier for your brain to handle by just flipping the middle terms. So instead of having plus 6x minus 4x, I can write minus 4x plus 6x. Now if I do the grouping, we can pull out a 2 and an x from 8x squared minus 4x. So 8x squared minus 2x leaves me with 4x. And minus 4x divided by 2 out. How silly of me. They're both divisible by 4. They're both divisible by 2 as well, but they're both divisible by 4. So 8x squared divided by 4x leaves me with 2x minus 4x divided by 4x minus 1. Both of these are divisible by 3, leaving me with 2x minus 1. So 2x minus 1, we just pull up binomial, and then we're left with the 4x plus 3. Factoring using AC method again. So we have 6x squared plus 5x minus 6. So AC is going to be 6 times -6, so -36. So I need two numbers that multiply to give me the -36, that add to give me the 5. I think it's possible this one doesn't work. So we're going to have our choices. We need a negative, right? Well, 6 and -6, we know we can try that. We can do 9. Oh no, we have one that works. We have the 9s. And like I said, just remember, you can flip them. But we know this is supposed to be a positive number, so we want to make sure the larger number is the positive. We have 12 and 3 is another one we can do. 12 and -3. And like I said, you could do -12 and 3, but we know that when we add those together, it's going to turn out to be a negative. So if we do 6 minus 6, well, that is 0. If I do 9 minus 4, that is 5. And if I do 12 minus 3, that is 9. So this is the one that we needed. So 6x squared plus 9x minus 4x minus 6. So remember, it's just this middle term we're breaking up. That still would sum to a 5x. I can pull out a 3x from 6x squared and 9x, leaving me with 2x plus 3. I can pull out a -2 from 4x and -6, leaving me with a positive 2x plus 3. So I can pull out my 2x plus 3. Oh, yeah, sorry, I got the wrong number and I wrote that. 2x plus 3. And then we're left with the 3x minus 2. And like I said, you should be checking these as we go along. I'm just cutting out some time for us.